In this video, we will be talking about density. By the end of this video, you should be able to explain what density is and give an example, and use measurement and calculations to determine the density of different materials. You might have noticed that sometimes two objects that are the same size and shape will not weigh the same. For example, a bowling ball is much heavier than a soccer ball, which is about the same size. Well, we should remember from an earlier lesson that weight is related to mass. So, a logical explanation for the fact that these two objects that are the same shape weigh different amounts is that they have different masses, different amounts of matter, different amounts of stuff in them. There is a physical property called density, which is a measure of how much matter or stuff is in a given amount of space. The more stuff there is in a given space, the higher the density. Imagine you have a bunch of marshmallows and you have two boxes that are the same size and shape. Well, let's put a few marshmallows in one of the boxes. Now, what would happen if we shoved more marshmallows into that box? Let's compare. We can say that the box on the left has low density, and the box on the right has high density. The boxes are the same volume, the same size and shape, but there is less matter in the low density box than there is in the high density box. Soccer balls and bowling balls, they're not filled with marshmallows, but if you were to take them and break them down and break them down again and break them down again, you would find that they're both made of very tiny particles. And these particles have mass. And this bowling ball has more particles than the soccer ball, but in the same amount of space. It's like you've squished more matter into the bowling ball. And since there's more matter in the bowling ball, its mass is greater than the mass of the soccer ball. And because the larger the mass, the higher the weight, the bowling ball, which has more mass, is heavier than the soccer ball. The bowling ball is denser than the soccer ball because there is more matter in the same amount of space. We can think about density mathematically too. The mathematical formula for density is this. The D, which stands for density, equals M, which stands for mass, divided by V, which stands for volume. When we put it in this fraction form, that line in the middle tells us that we divide the top by the bottom. And we can use this equation to determine the density of an object. For solids, density is measured in grams per cubic centimeter or kilograms per cubic meter, but we're usually going to be using the grams per cubic centimeter. For liquids and gases, density is usually measured in grams per milliliter because we tend to measure liquids and gases in milliliters. Let's do an example problem. We are asked to calculate the density of mercury if 100 grams occupies a volume of 7.36 centimeters cubed. Let's break this problem down. Let's start with what we know. We know that the mass is 100 grams. We know that the volume is 7.36 centimeters cubed. Now we need to find the density. So our strategy is to take our density equation and we are going to substitute our values into it. We're finding density, so it goes on the left. And then we're going to take our mass and we are going to plug it in where the m is. And then we're going to take our volume and we're going to substitute it for this V. So we have density equals 100 grams over 7.36 centimeters cubed. And when we divide it out, our density equals 13.6 grams per centimeter cubed. Now, one thing you should also know is that both volume and density are physical properties. We don't have to cause a chemical reaction in order to be able to observe these. So these are both physical properties. In summary, density is the amount of mass that is in a given amount of space. The more mass there is in a given space, the higher the density is. We can use a mathematical formula to determine the density if we also know the mass and the volume.